Now, this is all of you. Now, audible to all of you. Yes. Now, audible to all of you. Can anyone please reply? Hello. Can anyone please reply? Am I audible to all of you? Am I audible to all of you?
Yes, sir.
Okay. So let us start now. So how will we start it? First of all, yesterday we solved the two numericals, right? Today there is another one numerical left. So going to the next topic. So let us first solve this, right? So we just solved example 2.1, 2.2, and 2.1.2 yesterday. So just solve this numerical 2.3. Okay, check it out. Try to solve it out. Here you are having two equations. So for the angles, two different angles, there are two different resultant forces. Now we have to find out the respective forces. Try to find it out if you can, or else we will discuss it. So will you guys try to solve it? Are you trying to solve?
Yes, sir.
Okay, just try to solve it. Good, very good. Just try to solve. Is anyone able to solve it? Is anyone able to solve it? Someone please respond. Is anyone able to solve it? No, sir. What about others? Some people say it is not a fact. What about others? Are you able to solve it? No. If I, sir, F1 is Rian Deka. Okay. So someone give the answer. Yes, it is correct. F1 is correct. Yeah, one people has solved it. F1 is correct. Very good. What is F2 then? Yeah, F1, F2. Yeah, good. Very good. One person has solved it. We got one answer. Yeah. What about the rest one? Just give it a try now. If you can't, it's okay. Just give it a try. If you don't try, then yeah. Okay. Priyansh Debarma and Riyan Daka has submitted the
Sir,
correct answer.
it's F1 is equal to 1. Sir, F1 is equal to 1
Hmm.
and F2
But
is equal to 3.
now तुम्ही उल्टा धरू शकतो. Jalaluddin. F3 will be
Sir,
3, F1 will be 3, and F2 will be 1. Okay? तुम्ही उल्टा तो धरू शकतो. It's okay. It's okay.
okay, sir.
It's okay. No problem. But you have to be more particular. हाँ,
Okay, sir. Okay, sir.
ठीक है? Okay. 3 people.
Okay, sir.
Okay. Priyansh. Yeah. Okay. 3 people has given me the answer. Out of so many people. Yeah. So whatever, whatever others, I need at least one or two more answers. Then I'll go to the explanation part. Okay. Manas. Okay. Four answers. Okay, I'll give you one more minute, then you'll do a question discussion. This engineering mechanics class, all of you should carry your copies, okay? Then, there will be some days when the numericals will be done because a numerical based subject. Without numerical, your concept won't be correct. So you should carry a copy along with you while doing the class, okay? Telling to everyone. Atisha. So okay, 5 people has given me the correct answer. Very good, very good. So now what I will do is, for the rest of the people, let us discuss the Okay. Now, if you see here, this is the question. Okay. Find the magnitude of two forces such that if they act at right angles, their resultant is root under 10 Newton. But if they act at 60 degrees, their resultant is root under 13. Okay. Okay, so the question I just made a mistake. Okay, your answer is correct. It's okay. Uh, this root 10 and root 13 thing, actually, I just made it 13 and 10. It's okay. It's okay if you've done it. Just the procedure is important. Okay. Now, it is given two forces F1 and F2. Now, first of all, let us consider that two forces are acting at right angles. Okay. Now, if two forces are acting at right angles, when the angle between the two forces is 90 degrees, then the resultant force R is what? Root under R equal to root under F1 square plus F2 square. Okay. Now, squaring both sides will get 10 equal to F1 square plus F2. So this is equation number 1. Fine. Now, similarly, if the two forces is 60 degrees, then what will happen? Root under R equal to root under F1 square plus F2 square plus 2 F1 F2 cos theta. Then we get this expression, squaring both sides. And we have got a relationship between F1, F2. Okay. Just by substituting for F1 plus F1 square plus F2 square equal to 10. Here we are substituting by 10 and then we are just getting it in this manner F1. Now, if you see here, F1 plus F2 whole square equal to F1 square plus F2 square plus 2 F1 F. This is A plus B whole square form. So we just can write F1 square plus F2 square, you know, is 10, right? It's a no. And 2 F1 F2, where F1 F2 is what? 3, right? So F1 F2 is 3. Then 2 F1 F2 means what? 2 into 3 is 6, right? So we are getting it in this manner, like 10 plus 6 equal to 16. Why 10? Because 10 is coming from F1 square plus F2 square. And 6 is what? 2 into F1 F2. Now this F1 F2 we just found out to be 3. Right. Now we just can think like this. We just can sort like this. Now F1 plus F2 whole square we got in how much? 16, right? So that means what? F1 plus F2 equal to square root of 16. That means 4. Similarly, if you do F1 minus F2 whole square, then you have that same formula. Same thing. We just put it like that. F1 square plus F2 square we know this one 10. Yeah? And 2 F1 F2 is 2 into 3 the 6. That means what? 1 is 10 plus 6 for plus sign. And here it is 10 minus 6 for minus sign. Right. So it is 4. Yes. So F1 square minus F2 square F1 minus F2 whole square is equal to 4. That means F1 minus F2 equal to 2. That means if you solve F1 plus F2 equal to 4 and F1 minus F2 equal to 2, then you will be getting what? F1 is equal to 3 and F2 equal to 1 Newton. That's it. Is it clear? Is it clear for everyone?
Yes, sir.
Yeah. What about others?
Yes, sir.
Okay,
Yes, sir.
good. So this is just simple. Just think it analytically, you will be able to solve. Now we'll go to the next list. What? Yeah. Resolution of a force. What is resolution of a force? Resolution of a force means what? The process of splitting up of a force into number of components without changing its effect on the body is called resolution of a force. That means what? This is the inverse of resultant. We'll be explaining in a simple manner. Suppose this is the force F. Now we have to resolve it in Generally, resolution of forces, remember one thing always, resolution of forces are being done in two mutually perpendicular directions. That means what? In x-axis, we'll make one component, and in what? Y-axis, we'll make one component. Suppose here in x-axis, we just consider it as fx. In y-axis, we just consider it as fy. This basic thing, this division of the main force f of f into f of x, I mean f of y and f of x, this is known as what? Resolution. Of what? Is clear? What is resolution of force? I hope it is clear for all of you. Now we go to what?
Yes, sir.
Yes.
Okay, good. Now we go to what? Principle of resolution. So what does principle of resolution states? States that the algebraic sum of the resolved parts of a number of forces in a given direction is equal to the resolved part of the resultant in the same direction. That means what? Just we will go to the previous diagram. We go to this previous diagram. Now in this diagram, if you can see, the algebraic sum of the resolved parts of a number of forces in a given direction is equal to the what? Resolved part of the resultant in the same direction. Now this is the resultant, right? If this is the resultant, then the algebraic sum of the resolved parts. That means if this force, if this force, and if this force, it is resolved again, and that resolved parts algebraic sum is taken out. Suppose it is in this direction. Then it is equal to what? Resolved part of their resultant. Resultant F. So this is the resultant, right? In the same direction. It means if you resolve this one, inverse of the previous step, if you resolve these two forces, then the algebraic sum of these resolved parts is equal to the of the resultant in the same direction. So in general, the forces are resolved into what? Vertical and horizontal direction. Okay. Now we go to the method of resolution for the resultant. So how to actually resolve a resultant force? First of all, resolve all the forces horizontally and find the algebraic sum of the components. That is summation of H. First of all, you have to resolve all the forces in horizontal directions. Okay. Then you have to resolve all the forces in vertical directions. Then the resultant is given by what? Summation of h squared. H squared means summation of all the vertical force, horizontal forces plus summation of all the vertical forces that you have resolved. Okay. Then the resultant force will be what? Inclined at an angle of theta, such that tan theta equal to summation of v plus summation of h. Okay. Now, suppose this is f. Now, if you resolve it in x and y direction, then what happens? This is f of x, this is f of y, and this is f of x. That means what? You are resolving this force. Now, how to resolve, we'll definitely discuss in the later part. Now, this is f of x and f of y. Now, this summation, that means summation of the forces. Suppose there are multiple forces. Then this is f of x1. Then we have resolved this part, this one. Oh, this is f of x2. So in that manner, okay, x1, x2, right? So here also be y1, then f of y2. Okay. So in this way, if you resolve it, then the resultant is given by what? Summation of h square plus v square. Summation of horizontal forces. That means in the horizontal direction, what is there? F of x2 plus f of x1. Similarly, in the vertical direction, what you have? F of y1, f of y2. Okay. So these are the summation h and summation b. And the resultant force will be inclined at an angle theta, the horizontal, such that tan theta, that means the inclination angle, is equal to del v by del h. So this is how you have to find it out. Is it clear for everyone? Is it clear, everyone?
Yes, sir.
Okay.